So this video is a follow-up to my previous one, which was about using the quadratic formula to factor, and that's what this one is also about. How to use the quadratic formula to factor a second-degree trinomial, except this time we have a harder problem. The problem I did last time was fairly easy, and it was a problem that I don't think most people would be tempted to use the quadratic formula for. However, this one's different. So, here we go. I am not going to go through the quadratic formula this time because I did that on my last video. But I will keep it hanging out in the corner there. So, here's my problem. I want to factor 6x squared minus x minus 12. This problem is harder because the leading coefficient, the number in front of the x squared, is not a 1. Therefore, this makes this automatically harder to factor. That being said, this is not the worst factoring problem in the world, but we don't want to think. So, just like last time, if we want to use the quadratic formula, we have to change the question. So here's my new question. Solve for x. 6x squared minus x minus 12 equals 0. Once again, I have made up my own problem instead of solving the one I was asked. But we can use the quadratic formula on this one. So once again, we're going to match up the letters. A is 6, B is negative 1, and C is negative 12. So, here's the quadratic formula, and we're going to replace the letters. B is negative 1, so we'll replace that. Notice in the beginning my use of parentheses. Yep, we have negative, negative 1. That's correct. It looks stupid, but that's correct. Anyway, A is 6, so we'll replace the A's with 6. And C is negative 12, so we'll replace C with negative 12. Now it's time to do some cleanup. As I said before, negative, negative 1 looks stupid. That's just 1. In the denominator there I have 2 times 6, so we'll just make that 12. And now we have the messy radical, so just like last time I'm going to separate it out and clean that up on its own. Negative 1 squared is just 1, so it's a little better. Then I've got 4 times 6 times negative 12. The numbers get a little big here, so if you want to pull out a calculator, that's fine. But 4 times 6 times negative 12 gives me negative 288. Again, I have that double negative there, which I'm going to make that plus. 1 plus 288 is, of course, 289, so we'll change that. 289 happens to be a perfect square, and if you take the square root of that, that's 17. So, I can make my quadratic formula problem look a lot nicer. Alright, onwards. Here's what we've got so far. Once again, to deal with that plus or minus, this splits into two different problems. We got 1 plus 17 over 12 and 1 minus 17 over 12. Just like last time, I'm going to clean those up. 1 plus 17 is 18. 18 divided by 12 does not go evenly, but we can reduce the fraction. Both of those are divisible by 6. So 18 divided by 6 is 3. 12 divided by 6 is 2. So that's 3 over 2. For the other one, 1 minus 17 is negative 16. Once again, negative 16 over 12 doesn't go evenly, but you can divide them both by 4 and reduce the fraction. So now I have the answers to the problem I made up. We have to manipulate them to get the answers to the real question. But this one's a little harder. Like I said, now things get a little bit more complicated. The original problem was to factor that. It's helpful to know what the answer is supposed to look like. Presumably you've done factoring before. Because the leading coefficient on the x squared is not 1, our answer's got to look something like this, where the blank spots get filled in with numbers. So we want our answer to look like that. No one ever factors with fractions, so we want whole numbers. So, here's what we're going to do. We take our answers, and just like last time, I want them both to be equal to 0. So we'll subtract 3 halves from both sides. And we'll just manipulate this one first. As I said, no one ever factors with fractions, so I need to get rid of the fractions. So we're going to use this algebra trick that is known as clearing the fractions. basically I'm going to multiply everything by 2. And I mean everything. That looks horrible, but, well, 2 times x is just 2x, and 2 times 0 is 0. 2 times 3 halves actually works out really nice because the 2's cancel. So we're just left with that. 2x minus 3 equals 0. That's pretty. That's what I want. So we'll leave that alone and go on to the other. Same trick. Add 4/3 to both sides. And I'm going to multiply everything by 3. That looks really bad. But when we simplify it, the 3 times the 4/3, 3's cancel, and we're left with 3x plus 4 equals 0, which is pretty. Now these two equations look like factors. So once again, we're going to multiply the left sides together and the right sides together. Basically just write them down. We've got that. 2x minus 3 times 3x plus 4. And that kind of looks like that might be the answer. We'll check by the way you'll always check factoring, by multiplying it out. So I'm going to use standard FOIL technique. And of course on the right hand side we've got 0 times 0. So if I combine like terms here, I get 6x squared minus x minus 12 equals 0, which is what I started with. So in conclusion, 6x squared minus x minus 12 factors as 3x plus 4 times 2x minus 3. And we have done it. So here's the important question, is this method easier? I don't know. That's up to you. But it is valid. So there you go. Thanks for watching. And here's a baby seal.